Unit 2 is all about weighted voting systems, and in this lesson we're going to talk about calculating the Shapley-Shubik power distribution. Here's our class example for this unit, but this time instead of calculating the Bonzoff power distribution, we're going to calculate the Shapley-Shubik power distribution. In order to do that, we're going to need to learn about sequential coalitions. Here's our weighted voting system. When we built our list of coalitions, we came up with any combination of any number of players. With sequential coalitions, we're now talking about an ordered list of the players, and the order goes from left to right. What we mean by order is which order did the players join the coalition. Every coalition will have all players in it. The first coalition that we'll write down has player 1, then player 2, then player 3, then player 4. And this is the correct notation for sequential coalitions. It's important to use correct notation so you can tell the difference between a coalition and a sequential coalition. When we write a sequential coalition in this way, we're saying that player 1 started the coalition. Player 2 then joined player 1. After that, player 3 joined, and finally, player 4. Shapley-Shubik power is all about pivotal players. The pivotal player is the player that once they join the group switches from a losing coalition to a winning coalition. Let's list out all possible sequential coalitions. That is, all possible orderings of players 1 through 4. Instead of having player 1, player 2, and then 3 and 4, what if we had player 1 start it, then 2 joins, then player 4, and finally player 3? That's a different sequential coalition. We could also have the order of player 1, player 3, player 2, and finally player 4. Or player 1, player 3, player 4, and finally player 2. I'll fill out the rest of them here. And those are all the possible sequential coalitions with 4 players. Notice that I didn't write them with anything other than P1 through P4. That way, next time I need all the sequential coalitions for 4 players, I already have them and I don't have to make up the list again. Let's for a moment talk about how many possible sequential coalitions there are. If we have 4 players, each sequential coalition has 4 players in it. Think about how many choices we have for each of these spots. In the first position, I have 4 options for which players could come first. Once that player is determined, there's 3 options left for who could come second. Then there's 2 options left for who could come third, and finally there's only 1 option left for who comes last. In order to determine how many total choices we have, we do 4 times 3 times 2 times 1. So in this case, with 4 players, there is 4 factorial, or 24 different sequential coalitions. In general, that means that if we have n players, we have n factorial coalitions. Now let's start calculating our Shapley-Shubik power index for each player. Like I mentioned previously, Shapley-Shubik power depends on the idea of the pivotal player. If we're looking at a sequential coalition, we want to begin counting votes from left to right. At some point in that coalition, there's enough votes to win, and the first player that joins and makes that possible is the pivotal player. For each player, the number of times they're pivotal is that player's pivotal count. Let's look at our sequential coalitions again through a lens of looking for pivotal players. Starting with our first sequential coalition, we have player 1 with 5 votes. Once player 2 joins, there's a total of 8 votes, and it's a winning coalition. So in this case, player 2 is the pivotal player. Same for the next sequential coalition. Player 1 plus player 2 is a winning coalition. In our third one, we have player 1 with 5 votes, and then we add player 3 with another 2 votes. That's 7 votes, and it becomes a winning coalition. So in this third one, player 3 is the pivotal player. In the fourth one, we again have player 1 and then player 3. Player 3 is again pivotal. In the next one, we first have player 1 with 5 votes, and then we add player 4 with just one more vote. That's only 6 votes. So it's not until player 2 joins the coalition that it's a winning coalition. So player 2 here is pivotal. In the next one, again, it takes players 1, 4, and 3 for a winning coalition. So player 3 is pivotal. Now if a coalition starts with player 2, we start with 3 votes. Adding player 1 to that makes 8 votes, and player 1 pivots the group from being a losing coalition to a winning coalition. Again, we have the same scenario in our next sequential coalition. Once player 1 joins, it's a winning coalition. In our next one, we have player 2 with 3 votes, and then player 3 with 2 votes. That's only 5 votes and not winning. It's not until player 1 joins that they then have 10 votes and it's a winning coalition. I'll keep going. Now that we know which players are pivotal in each sequential coalition, we can find the pivotal count for each player. For pivotal count, we use the notation SS. So for player 1, they are critical 16 times, so SS1 is 16. Player 2 is critical 4 times, so SS2 is 4. Player 3 is also critical 4 times, so SS3 is 4. Player 4 is never pivotal, so SS4 is 0. Now that we have the pivotal count for each player, we can calculate the total pivotal count. Think about what this is. There's one pivotal player for every sequential coalition. There's also n factorial sequential coalitions. So every time the total pivotal count is equal to the number of sequential coalitions, or n factorial. In this case, we have 4 players, so there are 4 factorial sequential coalitions, or 24 sequential coalitions, 24 pivotal players. The SSPI, or the Shapley-Shubik Power Index for each player, is calculated by taking that player's pivotal count and dividing by the total pivotal count, or n factorial. Our total pivotal count is 24. So dividing each pivotal count by 24, we can find the SSPI for each player. Here we use the Greek letter sigma. Player 1 was pivotal 16 times, so sigma 1 is equal to 16 divided by 24, which simplifies to 2 over 3. Player 2 was pivotal 4 times, so sigma 2 is equal to 4 over 24, which simplifies to 1 over 6. Player 3 was also pivotal 4 times, so sigma 3 is 4 over 24, which simplifies to 1 over 6. Player 4 was never pivotal, so sigma 4 is equal to 0 over 24, which of course is 0. Switching these to percentage form, we have the following. We can now see the Shapley-Shubik power distribution for this weighted voting system. We can see that player 1 has 2/3 of the power, players 2 and 3 each have 1/6 of the power. Player 1 has 66.7% of the power, leaving players 2 and 3 for 16.7% of the power. And of course, player 4 still has 0% of the power, even when we calculate it like this. Player 4 is still a dummy player. And that concludes this video lecture on the Shapley-Shubik power distribution.